Hello everyone and welcome to another episode of DataStax Monday Learning. Hi Cedric.
Hello, Alex.
Yeah, so I see some people have joined us already. It's a big pleasure to see you all here. So if you can see us, if you can hear us, please set your thumbs up in the YouTube chat or Discord chat so we will know we are together and we can start.
Yeah, so today I will track the YouTube chat. So if you do have a question, don't hesitate. I will stop Alex if we need to, or if not, I will try to answer you back in the chat.
Yeah, exactly. So, it looks like we are good. I think we have sound. I think we have everything what we need. So it must be good to start.
All right.
Yeah. Okay. So I believe some people here who attended one of our last events, doesn't matter if it's a Cassandra workshop series or maybe DataStax Monday Learning, we will introduce ourselves and you will know what's going on. But in very short, DataStax Monday Learning is our way to make your Monday your best and most beloved day of the week, because we are always trying to do something special on Mondays for you, and we picking the most important technical topics only from engineers to engineers, no marketing bullshit, absolutely for free. Yeah, I mean, I
Yes.
hope no one of marketing is watching this video.
No, they are not awake. But one important point as well is it's kind of beginner content on Mondays. So you can start from scratch and learn.
Yes, exactly. So we want to cover important topics for those who are not so much into the things. Like today we are going to speak about. Oops. Today we are going to speak about machine learning, but not in the scientifical way or not in the very deep dive way. You don't need to have a mathematics degree to get into that. We always speak about complex things in a very simple way, so even if you are a complete beginner in this field, you can get everything we are talking about. By the way, as we are speaking about DataStax Monday Learning, next week we have something interesting, especially for those who is already into the Docker things or maybe who attended our Docker learning path. Next week, we speak about Kubernetes native applications, and will be a great expert in this field, a guest speaker, which is not a part of a DataStax developer advocates team. And that's great because we love guests.
Yes, we do.
Okay. And today is going to be Introduction to Machine Learning with Apache Cassandra and Apache Spark. We want to be practical, so we don't want this workshop to be too theoretical. We want you to be able to put your hands on and use real applications and real systems people use to apply machine learning into the real life. So, and let's just 2 words about ourselves. You maybe know us already. That's Cedric on the left to me, and or on the right. I don't know. Yes, on the
This
right.
side.
This side, exactly. And well, we work at the DataStax, the main company, let's say, behind Apache Cassandra, making Apache Cassandra happen, and we work at the developer relations team. So we are engineers and developers, helping our developers to get better with the distributed applications and all the modern technologies. And Cedric, maybe you will say something?
Yes.
Yep.
Sure. So I'm Cedric Lenven. I'm leading the developer advocate team. And also, I'm quite a Java geek. So I created FFOJ 7 years ago already. Wow. But it's pretty successful with 150K downloads a month. So it's feature flipping for Java. So meaning you can enable or disable part of your application at runtime. And I also had the chance to contribute to Jeepster. So Jeepster is a scaffolding application, a generator of application. You provide the technology you want to use and the entity, and that program will start you a full running app front end in JavaScript, Vue, Angular, or React and backend as a Spring Boot, and now you can also have the backend with Micronaut, and the ecosystem is just becoming huge.
Yep, and as you see, we are big fans of open source software, and that's exactly the thing for today's workshop as well as for every of the DataStax Monday learning. We are going to do all the things with open source technologies only. Okay, so a few things we are going to do today, and few things you have to understand, like where and what is stored and available and what you may need. Streams. That's a live stream. I hope you are watching it live, but if you don't, that's still fine because all the materials stay available for you. So at first we stream at Twitch and YouTube, but YouTube is the primary platform for me, so Twitch is a fallback plan B if something goes wrong at YouTube. Then, to ask questions, you can ask questions at the YouTube chat, but as long as the YouTube stream is over, chat is gone, and you will not be able to ask questions after that. To work more permanent manner, we use Discord, and you can find us at Discord. Maybe, Cedric, could you please copy paste the link to? Oh, thank you. You are thinking just ahead of time.
Yeah, you don't even have to talk now. You would just, what do they call that in English? Butter and chocolate? Chocolate and peanut butter? Yeah.
Something like that. Yeah.
We're working more like a binôme now.
Good. Now, the next thing, as we are going to push our hands on and press some buttons, we will need some runtime. In our case, as it's the introduction to machine learning, first, with Apache Cassandra and Apache Spark, second, we are going to use Apache Cassandra, Apache Spark, and a couple of tools required to apply machine learning to them. And it may sound pretty complex, but don't worry, we have everything set up for you. And to use that all together, you may need some materials. Those are stored on GitHub. And let me guess, Cedric has put a link already?
The
not
link
yet,
is
not
shrink.
yet.
No, because in the description, the link is shrink. So,
yeah,
I need 1 more minute.
Don't worry. In the description, link is a little bit outdated, I would say. I have to fix that, but actually, we have a newer link.
Okay, providing the proper link now.
Yeah.
Done.
So it's going to be
Academy. Everything is on DataStax Academy GitHub account. Yeah. There you can see all the topic we have covered now. We do have more than 50 workshops now there for you.
Yeah, definitely. Yeah. A lot of things. Good. So, and to do practical steps, you will have to choose if you want to use your environment or our environment. Your environment, whatever would it be, requires only a couple of things. You need to have Docker and Docker Compose. As long as you have Docker and Docker Compose, you can git clone or just download our assets from Machine Learning Workshop Online repository at github.com, DataStax Academy Machine Learning Workshop Online, and then you can just Docker Compose, pull Docker Compose up, and you have all the required things running. What is running there, I will show you later on during this workshop. But what I kindly ask you, first please, follow me and follow Cedric and do the practical steps after the theoretical part of the workshop, okay? So it will make things much easier to you if you listen first.
True.
If by any reason you can't have Docker and Docker Compose installed on your machine, or maybe your laptop is not so powerful because, well, we are going to run pretty a lot of things to make the computations, you have a second option. You can contact me in LinkedIn or via email, and I will create a cloud instance with all the requirements installed for you. Second option is maybe not so much comfortable because it's going to be temporary instance and we will terminate it pretty soon. But for some hours, 2-3 hours, it definitely can be granted to you. Well, so let's start then. Machine learning. Machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Sounds great, computers learn without explicitly programmed, but how it works in real life? Yeah, I've copy-pasted here a definition from Wikipedia, and that's as much as usual, mostly useless. If you know what's already, you don't need that, and if you know that, and if you don't know, it will not help, because all of those definitions are too big and too complicated. I prefer to use another definition which is much shorter. Machine learning is a science of drawing circles and colorizing them. It still explains nothing, but at least it's short, so it's already much easier to learn. So we better will think of how it works first, and then you will find which definition is better or better works for you. Machine learning is a scientific way to process raw data using algorithms to make better decisions. In general, it works in a very simple way. You have accumulated some data, for example, of your customers' behavior, what they're liking, what they're not liking, or maybe data from the medical point of view if you work in the medicine. Any kind of data people may be interested in, and then you process those data with some algorithms, helping you to make better decisions in the end. And there is no magic. Whatever machine learning does is the same thing as people could do, but you know what? Computers are computing much faster than humans. So basically, whatever computer machine learning can do, you can do as well. But in some cases, it may take pretty long time. What are the use cases for the machine learning? You will see some of them soon, but in general, that's very often about forecasts. What would be expected price or the best price for this product you are going to release? What are the possible ratings for, I don't know, for example, for a movie you are going to release or something? What are the possible weather in next Monday? Will you stay at home with us or will you go for a walk instead? I recommend you to stay with us because, well, DataStax Monday learning is a great thing. Then, another point, aberration detection. Whatever unusual behavior or unusual incident in the workflow, it can be about fraud detection in the banking, very often use case. Intrusion detection as well, any kind of, again, getting back to medicine, about the disease detection as well. Many others, typical cases for classification, face recognition, image recognition, categorization of the images, but not only images, of course. Spam detection, one of the most favorite usage of machine learning in real life is spam detection. We will investigate it deeper today. And also recommendation techniques, navigation, and many others. Machine learning is not more like just a fairy tale, but it's a real thing which got into every part of our lives. And we saw what that's about, applying algorithms to data to get some results, to get better decisions, to get some highlights over this data. What are those algorithms? There are a lot of them. We will take a closer look and something we will cover today. But in general, you may think of those algorithms kinda as of mathematical functions. As you give some data, you receive some result. If you have a function which multiplies everything by 3, and you give some data, some number to this function, you will have a result of a digit, number you gave multiplied by 3, and so on. So in general, algorithm is some simple defined way to execute some operations with the data you give. So nothing complex, and you will see it very soon on real life examples on how they work. And out of those algorithms, two main groups we may discuss, or two main cases: supervised and unsupervised. First of all, there are more cases and more groups. We may have kind of half supervised approach, and there are some more advanced things, but that's an introduction, not a deep dive, so we start simple. In general, all of the applications of those algorithms can be separated into two different groups, supervised or unsupervised. What's the difference? Difference is very simple. Data is labeled or not. If data is labeled or must be labeled as a result, it's the kind of a supervised algorithm. What does that mean? Very simple. We know already, we have some data, or we have to classify it. This email is a spam or not. This operation, this banking operation was a fraud. Subscription is cancelled or not. So that everything we can clearly say, okay, this operation is fair, this operation is fair, this operation is fraud. This email is spam, this email is spam, this email is not spam. We have this data already, and now we are getting new emails, and now we have to classify them or label them, speaking more scientifically. So data is labeled or must be labeled, and that's the purpose of the supervised groups. Typical cases is a classification as said. So when you have to say this is a picture of a dog and this is a picture of a traffic light. Classification, it's supervised. Then best side of a supervised algorithms, and they are easy to test. We will cover testing later during the making the steps how exactly it works. But in general, like a little highlight of what we are going to do, we split some data and we use part of the data we have to train the model. You will see how it works. And then we use second part of the data, smaller part, to test if it works correctly. And that's kind of this supervised thing is easy to test. Because, for example, millions and millions and millions of people getting emails over their life were sending some of those emails to spam. And that's spam, spam, not spam, not spam, spam, spam. That the job what we did, what I did, and you, I think, too, as well. And because of that, when I receive emails nowadays, and I'm using Google account for email, both work and private. You know what? They're really very good in the detecting which email is spam and which is not. Why? Because all the millions of the people were clicking spam or not spam all the years before. Okay, and then it's easy to test. Unsupervised algorithms, unsupervised approach is different. Data is not labeled, and we don't care about if it's labeled or not. That's not the thing for us. That's a different approach which helps us to find patterns in data, helps us to cluster data, so to separate data we have into different groups, to find groups and find dependencies between them. That belongs to anomaly detection. That belongs to any kind of a grouping of the data we have. That helps us to create associations between data pieces we have. Very useful in exploratory analysis when we don't really understand what data we have and want to get better knowledge of that. And another problem is, so it's harder to test because we cannot be really sure what that's the final result we want to have. Is it spam or not? We cannot say in this day. It's unsupervised, we don't have labels.
Yeah, and speaking of spam, I just, working with the marketing team, now we are also using some kind of machine learning to shape the email not to look like a spam. So you do have a machine learning trying to avoid you to get spam, and at the marketing side, we do have machine learning to push your email and make look it does not look spam. That's funny.
Yeah, someone said some time ago what in the 21st century every company has to become a data company or die. And well, that's not about just trying to collect as much data you may have, but that's about also to process that properly. Yeah, and that's very interesting. So now we have machine learnings from all the sides of this field, let's say. Okay. So let's take a look. Before we get a deeper dive into how it works, let's take a look, a little demo I want to show you. I want to show you a very simple thing. Those algorithms are in general simple to understand. Maybe hard to master, that's okay for me, but they're simple to understand. And first thing we will do is k-means algorithm, one of the algorithms we will use today. There is a great tool to play with k-means clustering algorithm. I will send a link to the chat. But please don't do it right now. First listen to me. Otherwise you will miss the explanations and then ask the things in the chat which we covered already. So, what's the clustering thing? Very simple. Oops. Okay. I will clean it up a little bit. Good. So, imagine that field is a city map. There are some streets and buildings, all the things like that. And you know what? We are going to create and deliver best pizza in the world. Like everyone loves pizza and we are going to bring it to a new level. So, and we are limited in budget, so we want to establish our centers, pizza houses in the middle of the area with the pizza lovers of this city live. So we want to be geographically convenient for them to visit, and also we want to keep it easier for our couriers to deliver pizza on very short time. And you know what? In the city, there are different areas. Some of them use and buy pizza a lot, and some of them are not. So, first thing I want to do as I'm setting, somehow we got data, I don't know, there are many ways to get data of the people living in different areas of the city. And those will be areas that people who buy pizza live. So I'm just making all the previous buys like that. And now let's take a look at what the k-means algorithm is. It's unsupervised algorithm. The data I have is not labeled. They all are the same, just only coordinates, for example, are different. That's a story of some orders of pizza I want to cover. K-means is not to categorize, but to help me explore the data and find how to group them or how to cluster them. It's a clustering demo, so we are going to build some clusters to group them. And as I have some data here already, and I will use default setting of 2 clusters to be fixed in the future, this one may work not the best. How this k-means algorithm works? First, it takes all the field I have here specified and randomly allocates, absolutely randomly, allocates cluster centers somewhere on the field. It may sound pretty stupid. I mean, like, I want to have more or less correct data, not some random allocation, but let's take a look how it works. In the end, after some steps of these algorithms, you will find out, you will see what it works pretty good. After those centers are allocated, it calculates the difference from all of the points to the current center and tries to find the best direction to move, the way which will decrease delta, which will decrease difference of lengths of all the lengths from the points allocated to the center. And I can push the step button 1 and use it the calculated steps. It moved them to the center. Okay, and it looks like delta now is already getting better with just 1 step, calculating all the lengths and moving in the center of mass direction. It's getting better, and actually only 1 step was enough to allocate the fix for us like that. But what will happen if I move center to a new position? It will restart everything, and I do the step again. So first thing algorithm does is calculates the length of all the lines we have here, and then tries to calculate in which direction we should move the center, so the groups will be identified in a better way. Okay. And this was identification. Like you see, we have pretty good situation here already. We are grouping them, but now some points belong to the red center, which is maybe not perfect in this case. And after a couple of more steps, okay, vice versa, we are moving in another direction. Red center gets points, those are closer to the red center than to the blue center, using exactly the same approach. After every step, they are trying to calculate which is maybe closer to me and should be consumed by one of the centers, and which one is any another center is not interested with. Then, after a few steps, with every next step, we are getting more and more better grouping for those, and in the end we have delta position 0. So it means what k-means algorithm doesn't want to move anything, it's fine. And now, why it's called k-means? K means number of clusters we are going to have, and that's one of the let's say biggest possibilities and problems of these algorithms. From one point of view, we may have limited amount of clusters right now. We have only 2, but maybe it will look better if we may have more clusters. And doing some steps, we find out what with 3 clusters it works better. Will it work better with 4 clusters? Well, maybe. Will it work better with 5 clusters? Maybe it's too much for us. So playing with amount of clusters and our way to group those cluster those data pieces we have to try to group them and find the centers of groups may work pretty good for us. One important point to understand here is amount of clusters is for humans to decide. We cannot just maybe you have some limited possible amount of things. Maybe it depends on what exactly do you have to find out. We discuss it on the next steps. In this example, I can put centers on my own. By default, k-means put them randomly, as I said. And then after every next step, we see how it changes and how k-means tries to find the geographical center. So again, process is very simple. You have this line, you have the set of lines, sorry, and you calculate direction and the length of every of them. And it looks like, oh, it looks like I have a very big delta here. Difference between my center and other center and the points of data is too high. And then obviously k-means will move this center more to the southeast, let's say. Boom, of course, because now it's the center. And now playing next step, we will find how it will reallocate and recalculate everything depending on the amount of clusters you have. So basically, that was a very simple example.
Yeah, so question in the chat,
Yep.
Try to answer, but so how do you set this K? Do you try and learn? So my first answer is this K is really tied to your own business. So if you talk about the pizza house, you have a limited amount of budget. So you can have 3 to 4 pizza houses. And so you will compute for each what is the distance between the houses and the data point, and see if it's worth adding a new pizza house. But I think you should try and learn.
Yep. Okay then. So what comes next? Now, okay, we just have seen one of the algorithms in the wild on how it works, how it measures distances, how it calculates vectors and moves the center to the best possible direction. How it works in real life and how do we apply data to the algorithm we are going to use. How goes the learning workflow? It consists of a few steps. At first, we have to prepare data because raw data is very often useless for learning. You will see it in the practical part. And first, we prepare data. When we split, if we work, in this case, we discuss supervised learning, so we can test. We split things into training set, validating set, and testing set we will need. Then there is a training phase when we train our model with a training set and use validating set to tune that. There are some things like K we can adjust and some others for another algorithms. And testing set we use finally to estimate our model if it's good or not. And finally, as if we are satisfied with our model, we can use it to work with the new data. If we speak of a spam example, here, first example, preparation. We have to get some emails and label them if it's spam or not. Let's say it's done for us already. When we split given emails into training, validating, and testing, and we use training set, which is usually biggest one, like around 80% of the data we have. It depends on your strategy, of course. To train the model, we use validating set to tune the model and find out if we can make it better, if we can reset up it maybe anyhow. And finally, we use testing set to estimate the model. And if model is good, we release the final model, which now is going to process the new data we have or new emails we have and set if it's maybe spam or not. Yeah, good. Now, you maybe want to jump into actions, but but before that, we have to discuss one more thing. So we are very close to practical. You cannot control what you can't measure. So we want to speak about metrics. As we work with a supervised algorithm now, we can test and we can compare and we can assess the model if it's good or not. So what kind of metric matters? Let's take a look and let's talk a little bit about the example we have. That's year 2020 and all the pandemic is going over. And I'm sorry to touch this topic, but I'm going to get into some medical things right now. For estimation and metrics part, we will talk about tumor. And in this example, we have 100 patients, 100 people. 9 of them have malignant tumor, which is very bad and kind of deadly. And 91 of them have a benign tumor, which is, well, also bad, but not so bad. And our model, we prepare it, and model which we are going to assess in the next step gave following results. Out of 100 people, 9 malignant tumor, 91 benign tumor, we detected successfully 90 true negative results. So they have benign tumor, not the malignant, and there are 90 of them. And we found out 90 of 91 of them, which looks not so bad. Then false positive results. We identified tumor as benign, but actually it being malignant. And false positive, we have only one result. So one person had a benign tumor, but we identified it as a malignant, as a bad one. Then we have also false negative. In reality, people had the bad tumor, but we predicted it as a light kind of tumor. 8 results false negatives. And finally, one true positive. It was very bad tumor, and we identified it as a very bad tumor. Number of true positive results, again 1. That's the example we will work with now. First metric we talk about the machine learning algorithms is the accuracy. Accuracy is a classification model metric. It's the fraction of a prediction model identified correctly. So, accuracy, easily speaking, briefly speaking, is the amount of correct predictions divided by total predictions. In this example, we have accuracy of 0.91 because 91 predictions were true. We have true positive 1, true negative 90, it total 91 divided by 100. So accuracy is 0.91. It's pretty high. Is that model good? Now wait for a second and try to think. Because, well, there is a flaw we didn't discuss yet. We just sent back home 8 people without proper treatment because of a high level of false negatives. Out of 9 people with malignant tumor, we got false negative on 8 of them. We could have better results literally by throwing a coin. I mean literally. In this case, we sent back home 8 people out of 9. And if we would throw a coin, this amount would be much lesser, most probably. So, is this model good or not so good? Well, maybe not so good. And we have to work on that. So, accuracy is an interesting thing. From one point of view, that's important to understand accuracy. From another point of view, you see, like, that's very clear. Is not about, it's sometimes not the best thing. We have high accuracy, highest possible accuracy is 1, and we have accuracy 0.9, very close, but the model is still very bad. So, let's take a look if we have something better. Another kind of metrics we have to discuss is the precision versus recall. Precision means positive predictive value. Precision means amount of true positives divided by amount of all positives, both true and false. And for our example, for our example with a tumor, precision is only 0.5. Which is not so high, so we see what it has, like kind of very medium precision. But if we go to the second side of the slide, which is recall, also known as sensitivity, recall or sensitivity, you can use both. Recall is maybe a more official name. Recall counts correctly identified positives out of all real positives. And recall is amount of true positives divided by all real positives. And for the tumor example, recall is 0.11, so extremely low. Now, well, then we have a lot of metrics, some more also coming. What people are doing in the real life, because yes, we need metrics, but now we see what accuracy is maybe not so relevant. And precision and recall, they are great, but they kind of contradict to each other. Then you start to tune your model to be more precise. You start to use recall. That's kind of a simple mathematic thing. Higher your precision, lower your recall, and vice versa. Then people start to use synthetical metrics, which use all of them as accuracy and precision and recall, like F1 metric, which is synthetical, consisting of multiple of the values like precision and recall. And in general, that's a long story. It doesn't matter if you don't get it too deep for now, because that's not the purpose of this workshop. The purpose of this workshop for you is to understand the basics, and in general it's very short. We can measure efficiency of algorithms, at least for supervised, and not all of the metrics may have, like, say, different relevancy for your use case. And one last thing before we go practical is I want to discuss underfitted and overfitted model. In this case, we have the same set of data processed with differently configured or maybe different algorithms. We are trying to predict some values on those things, and we have three kind of models, left, center, and on the right. And let's take a look at the left example. We have pieces of data, our circles, black circles here, and we have these dotted line. Dotted line is the prediction, is how our model works. And in this case, we see these result of this model aren't so good. It's maybe wrong algorithm or not well configured algorithm. And we see what this underfitted model is not accurate. It's just too simple. We have more complex set of data, and we have just one straight line. So that's a bad example. In the center, we have a good fit or robust model, which is well generalized. Model should not try to catch and be perfectly precise on for every dot we have. But in general, it should find, in this case, the general trend, the main idea of the data we have. And on the right side, we have overfitted model. That's exactly overtrained model, which tries to fit into every piece of data you have, and as a result, it's trying to be too much precise. It gives a bad result overall. It's overfitted model. It works perfect on the trained data because it fits literally into every point of the trained data you give. But then as soon as you start test and it found out like what something is not perfect, then it works not so good. Important for us, we want to keep our models general enough and we don't want them to be too precise. We will discuss it later, more practical on one of the models. And well, practice is golden, talk is cheap, show me the code, show me how it works. Very simple. Before we start, few words about the tools we are going to use. Luckily, those aren't the tools on the right, but more the tools on the left. I mean, well, it's still almost 2 months in year 2020, so we still have a chance.
Yeah. Oh man, that's you.
So, what we are going to use? First tool we are going to work with is the Apache Spark. Full title is an open source distributed general purpose cluster computing framework. My god, that even sounds awful. But explanation is very simple. Do you remember our k-means example? We had like around 100 of dots, and for every center of mass, let's say, k-means algorithm should have calculated the length and the vector, and if I should move in this direction or maybe move in that direction. So it's pretty a lot of computations, but in the real world you are going to work with maybe billions of rows of data. Explaining very simply, Spark helps you to run those computations on multiple computers at once, usually powerful servers. So whatever we do today on this example, you can calculate on your laptop, because we work with data sets of some thousands. But when you start to work with real big data, your laptop is mostly probably going to melt after an hour or maybe sooner. So for this, we in real world we use Spark, which helps us to distribute calculations over multiple servers. Spark is a great open source tool, and it works very well with the Apache Cassandra, which is a second tool for us. What is the Apache Cassandra and why do we care? Apache Cassandra is a free open source distributed decentralized NoSQL database. In short, it's a database which is a big data ready. It's ready to handle dozens petabytes and hundreds petabytes of data over the world. And that's one of the most powerful databases we have right now. For example, for a long time, we were sure what the biggest Cassandra deployment was done by Apple. You maybe have heard something about Apple. They released those mobile phones with Apple on the back. Doesn't matter. So their deployment was around 100,000 nodes. But funny point, we were wrong. because we found out what there is a company which has even higher number. With Huawei, China has around 160,000 servers dedicated to work with Cassandra. 160,000 servers to handle data. So that's something I call big data, really. And also there are guys like Netflix, Instagram, and so on and so forth. Good. So Cassandra is a database to store big data. I need to make good decisions in my business, for example. Then Jupyter and DataStax Studio. In our case, they are very similar by the idea. I use Jupyter to work with Apache Spark. For me, it will be just like a web interface to work with Spark, simplifying that. And I will use DataStax Studio to work with Apache Cassandra. You can consider DataStax Studio as a web interface for Apache Cassandra. Then Python. Well, I will not spend too much time explaining what the Python is. But well, you may want to know what Python is very widely used in the machine learning.
It's a reptile.
Yeah. When we have some libraries for Python, we will need to use today. Those are pandas. Pandas is the package providing all the tools you need to work with the data for machine learning analysis in Python. Then PySpark is a simple integration library which helps Python to work with Apache Spark. You will see. NumPy is a package for scientific computing with all the array objects, linear algebra, Fourier transform, and so on and so forth. And then finally, Scikitlearn. Scikitlearn is again a set of tools, I would say, big package, including many different things to help you not only work with data and run the machine learning algorithms and calculate something and predict something, but also visualize that, because, well, humans aren't computers. We prefer to see first. And how it works all together. So everything what we are doing, you can completely do with Apache Cassandra and Apache Spark. In our case, to simplify setup, we are using them packaged together already by DataStax. That's a package called DataStax Enterprise. It's free for non-commercial use, like that, for educational purposes. Basically, that's Cassandra, Spark, and some more secret things bound together. And on the left side, we see DataStax Studio to work with Cassandra, therefore raw data. And on the right side, we see Jupyter Notebook to work with already our machine learning code we will use. So that's how you work with a local environment, doesn't matter. But at first, I, as said, ask you to follow me and then do those steps on your own. Today we are going to cover 2 steps. And you will have 3 more tasks to do on your own via cloud instance or on your own laptop, as you prefer. First algorithm we will cover in the practical step is a naive Bayes supervised classification algorithm. It's a kind of very old algorithm and very well known in the machine learning field. What's that and how it works? As usual, Wikipedia definitions aren't so much helpful. Like, with all this, naive Bayes classifiers are a family of simple probabilistic classifiers based on the applying Bayes theorem with strong naive, and I don't like that. Let's move on and let's see how to explain that easier for humans. And funny enough, this comic is the best possible explanation of the naive Bayes. Simple as that. It's written in the scientific way, I will explain in a moment, but in general the idea is very short. If you pick up a seashell, fact number 1, and if you don't hold it to your ear, fact number 2, you can mostly probably hear the ocean. There is a trick of a chain of dependencies. We will work deeper on the next slide. But really, that's the best possible explanation of a naive bias. If you want to make a deeper dive, follow me. So, I'm going to apply naive bias algorithm now. First thing, we have to prepare and label data, and we will use very traditional spam problem. So there are, I don't know how many emails on the internet happen to be every day, but amount is tremendous. And
every second even.
yeah, every second,
Yeah.
and problem of most of them you don't want to read because they are trying to steal your money or steal your credentials or steal your something, I don't know, and we want to get rid of them. So first, as it's the supervised mechanism we discussed it before, we are going to prepare and label our data. What does that mean? Very
3
simple.
million per second. Okay.
Yeah. So that's why
Wow.
your laptop will be not enough, although it's a good laptop, but we still will need
Jeez.
Spark to run computations on multiple of servers. Yeah. So, well then.
Crazy.
In this example, we have 1, 2, 3, 4, 5, 6, 7 emails. There is very small data set. We agree like the amount is in billions and billions and billions usually. But you will be surprised at how good this algorithm works even based on those 7 of emails. So what's the first preparation we do? We work with the topics of the emails, subjects of the emails, and we have to label them, and we have to identify if the email is spam or not. As a result of those emails, we have this little table. We have 3 emails identified as spam, money transfer received, get cash easy, win money now, and we have 5 emails. Those are not spam. Greetings from dad. Could you lend me money? It was easy. I miss you. Check your trip itinerary. Like, should be more or less familiar to everyone. Some of them are spam, some of them are not spam. What we did right now, we prepared our data and we labeled this data. Very good. Now we know which email is spam and which email is not spam. First step we can do, and we will need that later, is we calculate the chance of email to be spam just based on the numbers. And the chance is pretty simple. It's 3 of 8 of email being spam in this example, and 5 of 8 email is not spam, based on those numbers we have. Can we improve this knowledge? Let's take a look. So, our database, small database, our data set, small data set on the left, and on the right we have a little story. I received a new email with the subject easy money. Is it spam or not? How humans say that? What is the chance it's spam if the subject is easy money? How scientists say the same idea? That's the formula you've seen already. Probability of this email is spam given it contains easy and money in the subject. What will it be? So this statement, what is the chance of it's spam if it has easy money, and this formula, let's say, this statement, they are exactly the same, but second looks more scientifical. So now you can write everything like that, then you are calculating probabilities, and now you will look like a data scientist. And now we start to think of the topics, the subjects. This email we are working with right now has easy money subject. So we analyze that step by step. We have word money in 2 out of 3 spam emails. So take a look. That's our spam data set, very small. Money transfer received, win money now. In 2 out of 3 spam emails, we have had this word. So probability of this email will contain now notice we have here spam and easy money. On the right side we have facts. On the left side we have what do we want to know. And now out of these money, 2 out of 3 spam has word via money, we can calculate what's the probability of this email contains word money in the subject given it's spam. We know it's spam, it was labeled before. We know what probability is 2 out of 3. And working with not spam, we know what only 1 email out of 5 got this word money. So we see probability, what word will contain, what email will contain money, if it's not spam, is 1 divided by 5. Then we do the same job for easy. Word easy was once in spam and once in not spam. 1 out of 3 spam, so probability word contains easy, sorry, there is a typo. In spam is 1 divided by 3, and 1 out of 5, 1 divided by 5. Now there is a lot of numbers, so maybe you dizzy a little bit. So okay, now we have a set of probabilities. How does that help us? Very simple and very cool feature. Conditional probability. The chance what this email is spam or not spam always equals 1. Because email cannot be half spam. Well, let's say it can be in some chances, in some cases, but we are discussing like the simple scenario, okay? So we know what email is or not, or spam or not. These probabilities counted together will always be equal 1. And now that's the heart of the naive Bayes algorithm. We calculating probabilities of these based on the data set we have. And that's a very long thing. And notice we are working off a very simple data set, like how much more computational power you may need to calculate similar things on the real data set. So we can cover that in this way. That's downstairs we have it with real numbers and here with explanations. Probability of the email is spam given it has words easy in money in subject is the result of all of the probabilities we calculated already. First is what's the probability of this email to be spam in general, when what it contains easy, and what it contains money. And intersection of first probability is going to be 1 divided by 12, or as a final result, when we are bringing them together, 10 divided by 13. Because we know what the overall probability can be only 1. And in the second example, probability what is not spam will be the same thing, but just apply a data set from the not spam field data. And we see what we have after processing very simple flow, which is very easy to distribute and calculate on multiple machines. We have what based on this data set of 8 emails, new email with subject easy money has probability to be spam over almost 77%. And that's the result of a very simple work on the 8 emails we have right now. And that's already pretty accurate, I would say. So, getting a little bit back how it works. It's a reversed dependency. First, we calculate these data on the simple way. So we have labeled emails. We know what money, what probability the email will contain. So we're trying to calculate probability this email will be spam based on the subject. And then we are using reversed thing, probability this email will contain one of the keywords we are looking for, given it's spam or not. So these numbers like 2 divided by 3, it comes from this data set of labeled emails. Money transfer received, get cash easy, win money now. 2 out of 3. And we are working only with subjects. Okay then. Bias algorithm we see, but why it's called naive bias? How it comes? Very simple. Naive bias doesn't consider a relation between facts. For example, if I write the word happy, probability of the next word to be birthday is kind of significantly higher than the probability of the next word to be funerals. And if I say long, long ago, chance what person next to me will proceed in a galaxy far, far away is higher than any another phrase, I don't know. This algorithm does not consider those dependencies. It's all isolated facts for this algorithm. It may look like pretty stupid, but surprisingly, it's not. On the big data sets, it's at some point doesn't matter after all, because usually you work with a data set not of 8 emails, but more like 8 billion emails. At this size, at this scale, it doesn't matter after all. And all what I say now is very easily explained on the right side of the screen, close to Cedric. From the human point of view, it can be or cold or warm outside. From the naive bias algorithm, those are isolated facts, and it can be sorry, it's always ready to answer without considering the dependencies between facts we are taking. And now let's take a look how it works. So you will do it on your own. We have a bunch of exercises to do. Now I'm at my Jupyter instance, and here I work with Jupyter. I work with Apache Spark via Jupyter and with Cassandra as well.
Yes. So to get the Jupyter, you can go, Docker compose up-d as written in the README. But hey, please follow Alex, and you can do the exercise later with your dataset on your own.
Yeah, actually, I know why people always run to do exercises during the workshop. Because people use it to, as soon as workshop is done, everyone quits and there will be no answer ever. That's wrong. We stay here for you. Even when workshop is done, we have our Discord server, so you can completely go to our main chat in our Discord and work with us and ask us questions, and we will answer.
Yes.
Workshop,
you can even create some dedicated rooms, for topics if you want. Please ask. We are 6,000 people in the Discord.
Yeah, definitely. So, workshop is not over as long as you don't want it to be over, okay? And now there is no need to hurry and try to do everything with me. You can do it alone and then ask questions via Discord.
Mm-hmm.
And yeah, as said, you can clone these DataStax Academy Machine Learning Workshop Online repo, or you can grab a cloud instance contacting me. So, as a result, you anyway going to have 2 web interfaces. One is Jupyter, and one is DataStax Studio. And we start with Jupyter. Now I want to work with naive bias. And this example was developed... hey there, I just clicked that. This example was developed by our former colleague, Amanda. And she's great. She now works at Apple, I believe. And we miss her a lot, but in her memory at DataStax, let's say, we will run this example. And this example operates wines and wine qualities. Why? Because we can. Well, you know, I'm Russian.
Because it's important as well.
Oh, okay. You know, I'm Russian, so I'm not so much into vines. I cannot analyze them, but maybe
but,
Cedric will help us.
yeah, but I wouldn't trust an algorithm to judge a wine.
So we will see if an algorithm works good or not so good. We will see. Maybe it's not the best way, and you know what? That's always about iterational improvement. You try this one, you train the model, you get the results, you assess the results, and you see if you are satisfied or you are not satisfied and there is something to change. So I don't know, maybe this algorithm will work not so good for us. Okay,
Yeah.
So what we are trying to learn from this data set? Question. Can naive bias be used to classify a wine rating score by its attributes? So we have a set of wines. People, some experts, try them and set some ratings. Like that's a great wine, this wine is not so great. And what we want to try with machine learning, in this example, we want to try to predict will those experts like our new wine, let's say, or not, and which kind of data we have. First of all, we have some wines with ratings already, and we also know chemical, how it's called in English, chemical.
Yeah, chemicals. It's chemicals.
Those chemicals it contains, and can it work together using naive bias or maybe not so much? So, how do you use Jupyter Notebook? This, you will have exactly the same thing as I have right here. You see what I've activated, naive bias notebook. By the way, it's important. Every notebook is a pretty big thing. It doesn't look like a big thing, but it's a big thing. So if you have all of them running, memory of your machine mostly probably going to be very busy. So what you want to do as soon as your notebook is done, I strongly suggest to shut it down. Otherwise, if you have 5 of the notebooks are running, it will be too tight for them to work efficiently. Okay, so there are some text fields I will not touch, and there are some executable lines I'm going to touch. To execute a line, I set my cursor on it so it's highlighted in green. I will try to make it a little bit bigger. Yeah, looks good. I think it looks good. Good. And
it's huge.
Okay, even better. And I will do it full screen. Yeah, great. And I push the run button to execute this statement. And first one is very simple. First two actually are very simple. I'm importing dependencies I will need. And you may see some familiar dependencies here. First, like pandas, we discussed it some minutes ago. Then PySpark, we used to connect to Python to Spark. And Cassandra, we used to connect to Cassandra. We will need some random things. And from PySpark, we import the most important thing for us, machine learning classification. We import naive bias algorithm, and we will need some vectors, vector assemblers, and string indexers to prepare data to be processed. Then, next step I want to do is just a little helper function. I run this string, not string cell. Cell is a better name. I run this cell to define a function I will need. If you are into Python, you know what that's the way how we define functions. If you are not, well, you can just trust me. It's good enough for today. That's nothing big, just helps us to display lines of code. And then we start to load data. First, to work with data, we will use Cassandra. You can do the same things, loading data directly from the files, but that's not how it works in real world. So at first we connect to Cassandra, and connected, and we are going to create a key space. We will store our data. If you attended one of our Cassandra workshops before, you know what does that mean. If you didn't and you don't know how Cassandra works, doesn't matter. Cassandra is just Cassandra's key space is just group of tables we are going to use together. So here I'm creating key space to store my data. Good. And I set this key space accelerate to be the default key space for me. And I create table. Create table if not exist wine. And that's what we have. We are going to have in this table. At first, every wine has 11 chemical values: acidity, volatile acidity, citric acid, and so on and so forth. And alcohol, like how much alcohol it has. Oops. And finally, the quality. Quality is the result of this wine being assessed by wine experts. Maybe Cedric was one of them. I don't know.
I wish I would.
Well, you still have enough time. Okay, so we created this table. We can double check that by going to our DataStax Studio, open our naive bias classification, and at first I may ask to describe key space accelerate. I have to make it a little bit bigger again.
Yes, please.
Good. So,
okay, good.
Yeah, it's here. We have key space accelerate, and we have table vines with all the values we discussed. And by the way, you see there is a lot of lines and properties we haven't defined, predefined properties for Cassandra. Cassandra is the best tool to manage petabytes of data and dispatch them within very tiny milliseconds. So if you work with high loads like that, you definitely want to attend one of our Cassandra workshops. Closest intro to Cassandra workshop happens to be this week, I believe.
Yeah.
Exactly, this Wednesday and Thursday, 2 times.
Yes. And you know what? I feel like, having Cassandra to help Spark to train the model is pretty relevant because you may want to use a distributed algorithm to train because it's a lot of data. And Spark is distributed, Cassandra is distributed. I think it's working well together, and it's not only using CSV files as you may tend to do when you're working with machine learning.
Good. Okay, so we have it prepared. Now we have to load dataset.
Love the pictures.
Yeah, well, that's Amanda. I would
I still want cheese now, That's...
Oh yeah, good. So we are loading wine datasets from CSV files. We have 2 CSV files prepared, one for red and one for white wines. So I simply execute this cell, and it will take some time because we are reading from 2 files and inserting data. Okay, it's done very well. So now we can again open DataStax Studio and ask to show those values. Good, and we see the data we have with all the discussed qualities. Very well. Then, finally, we are getting closer to Spark. So, Cassandra is very good when you have to store data and dispatch it on the production, real production workloads to not make your customers waiting. Cassandra is very quick. And now we need Spark to connect to Cassandra and load this data to execute machine learning operations. So let's take a look what's going on. I'm using previously imported Spark session builder with application name demo, doesn't matter. Master, so master of the Spark cluster will be local. That's a educational cluster, not the real big one. And I get or create the Spark. When I will execute it right now because it will take some time, so we can walk. When I have to define a wine data frame. To do so, I ask Spark to read data in the format Cassandra with options what I'm going to read. Table, wine, key space, accelerate, and I need to load this data. After that, I'm printing output What's the count of a wine data frame I've downloaded? Data frame is a Spark definition, not the Cassandra one, because here we are using Spark, as you could see. It only loads data from Cassandra. And we see what we have. Almost 6,500 wines and their estimations.
Whoa.
Yeah. Why do you need more than 2 wines, Cedric? I mean, white and red.
Because we are not Russian and drinking vodka.
Oh no, it's too complicated for me. But whatever.
There's some flavors, you know.
So we have show data frame. That's the function we defined in the beginning, just to keep it like nice. And we see what every wine has: ID, alcohol, some chemical values, and quality as well. Now, next thing, we want our wines to be the best. So we are going to filter out all wines with quality lower than 5. First, we are using the Spark feature called filter. So we are doing wine data frame dot filter quality bigger than 5. We define a new data frame, which will be wine 6 data frame with all the wines quality higher than 5. And we show this data frame. Boom. So now you see what I have all the wines in this list with quality 6 or higher. Good. Then we have to prepare data to be properly processed. So, as we are using naive bias, first everything has to be a vectors. To prepare that things, we are using vector assembler, and as an input columns we are using alcohol, chlorates, free sulfur, and so on and so forth. So all the chemical values we have, preparing these vectors needed for for the naive bias to be processed, and for us it will be just features as an output columns we need. And then we prepare training data we will use to train. With this assembler, we transform wine6 data frame and training data as a result of this data processing of wine6 data frame with all the high quality wines we have, prepare it for the training. Few more things we need to do. First one, we need to set the labels as discussed. That's a supervised learning, so we need labels. In this case, labels will be built on the quality because we are going to work with the quality. And output column will be just label. And as a result, we have here training data 1 using the values we prepared for us. So we get our label indexer, which is a string indexer based on the quality. We are trying to classify those wines we have into multiple groups based on their chemical values we are having here. We are fitting these training data with indexer, and finally transform with training data. And I'm launching these, and we receive the results. We are creating their vectors with all the elements of wine. In this case, everything is already prepared, and we have count of training data we have is 4,000. So we separated that and prepared it up. So we have 4,000 and something wines of quality high enough to participate in our learning. And now all the data is prepared, and we finished the preparational step. And we need to split up our dataset into training and set. Usually it works a little bit more complicated. So we need training, validating, and test set for cross-validation. As that's a simpler example, and starting from basics, we will have just training and test set, and we will split 80 to 20. So first we just split. We use training data with a random split, so they will be split randomly. Some goes to first set, some goes to second set, and proportion will be 0.8, 0.2. And we have as a result two sets here, train and tests. I'm executing this one. It's going to be pretty quick because we aren't doing learning yet. We just doing the separation. So we have 3,366 in the training set and 747 in the test data frame. And now it's finally time to launch that. We are launching naive bias. We define that first. We here train the model. We do with train data from the previous step. We calculate our predictions based on the test data using the same model. So here learning comes. Here we are doing our predictions. I'm launching that. Okay, so we are showing results of our predictions. In this case, quality is the new field predicted by our model. That's this field is not available, and we can run these predictions to show the most important thing for us: quality and label, predictions, and probability. So the fields required here. And now we train it our model. We process a test data. That's important to remember. Test data goes to model without quality. So the quality of that will be not available. That's our predictions already, not the values from the data set we have. And finally, we use multi-class classification evaluator to evaluate the accuracy of our predictions. So we did predictions. Are they good or not? So all the previous lines are executed, and now we can try to execute that. And we see what test set accuracy is 0.6. So Cedric, it looks like you were right, and machine learning, or at least naive Bayes algorithm in this case, is not the best way to try to predict the quality of a wine. Maybe we should simply ask you next time.
Maybe they need more data set. I'm happy to enter those data. I need to test the wine though.
Good. But that's not the end, because we have some more things to cover, so we will get back to this example very soon. The only thing I want to tell you is I want to shut down this notebook, otherwise I will have too much of the running notebooks in the end. Good. Okay. So let me get back. And now I want to take a look at another algorithm we may need to use today to get better prediction on the data set we were working with. A random forest is a supervised classification ensemble method. And notice that's not an algorithm, but the ensemble method. I was talking about algorithms, and now there is an ensemble method. What does that mean? Let's take a look. First, it all comes from a decision tree. On the left, you, as always, have the definition from Wiki, which never helps. And I want to explain that on the simple example on the right. Decision tree is a simple way, very simple, maybe one of the most simple algorithms possible. Decision tree is an algorithm which kind of answers questions yes, no, higher, lower, equals, not equals, and calculates things based on the answers, trying to combine different questions and answers. Decision tree for Titanic survival, on this case, is at first level based on the gender, at the second level based on the age, and in the third layer based on the siblings count, amount of brothers and sisters. So here with the decision tree, we are calculating what were the probability to survive in the Titanic disaster back in the last century. So, and that's a very simple decision tree because yes, they are simple. Decision tree algorithm tries to calculate the best possible decision tree based on the labels you are giving. And we see how in this case, answering first gender allows us, answering first question allows us to define the probability to survive, and if its situation is more complicated, then it tries to add more questions to answer with different values. If age is more than 9.5 years, probability to die for the gender male was 61%. And if age was smaller than 9.5, then it depends on the amount of siblings. This kind of decision trees are generated easily by the algorithms, and they have all a big problem. By it is a single decision tree has a strong tendency to be overfitted. It works perfectly with the data you're giving, training data, so generating those questions and answers and answering them. It behaves very good on the training data, but as soon as you give test data which was not available on the training time, it immediately start to give very wrong answers because it's overfitted, not general enough. To solve this problem, we use ensemble method random forest. Random forest is a method which unites multiple decision trees, and as those decision trees ask and answer different questions, they as a result give good general enough method. And although every decision tree is very simple by it is, they are also very good and reasonable, united by random forest method. My random forest by it is also has some configurable parameters. For example, you may say what every decision tree has the same weight of the answer, or you may say what the decision tree based on these values has higher weight for the following answer. In this case, we will use the very simple approach. So let's take a look. Maybe random forest will work better for us, and Cedric has something to be afraid of. I don't know.
I have no fear.
Good. So I'm launching my random forest notebook. And in DataStax Studio, I will jump back to notebooks and switch to random forest notebook. Good. So same data set. I may need to do a little cleanup on data maybe, but we will see. So run. First two steps should be very familiar to you. So I'm loading dependencies. In this case, it will be a little bit different because I'm going to use Python ML classification algorithm random forest classifier, which is again not an algorithm but ensemble method. Good. I'm defining the so that's a new notebook, and therefore it's a new environment. So I have to redefine things I'm used already. I'm defining the same showDF function for pretty formatting of the data we work to. I has to contact my Cassandra cluster, and I will use the same key space. It exists anyway, and I will use that for all my data. Good. So I want to kill this table and load the data again, but actually it should have the same data as far as I remember, so we can simply proceed to the next step. So table is available, data is loaded, and we can start to work with Spark directly. Okay, so we have the data here, and we see all the values we processed already. Now we will apply another approach. So that's always about iterative and trying to find something what works better. So I'm creating a data frame with one of the higher qualities. Good. And now I'm vectorifying data I'm going to work with. So that's the steps we did in the previous step. We will need indexers and vectors to prepare all the data to be strongly mathematical for the random forest to answer in the simple way. Very well. And now we have to split our data again into training set and test set. So you've seen that already. We will use train set to train model, and we will use test set to evaluate model if it's good or not. And now that's interesting thing happens. So we will use random forest classifier from Spark library. Label column, so the label we want to give will be label. Features column is the features, so that's the thing we prepare it in this previous step. And finally, number of trees do we want to have will be equal 10. Here we go with this step. So we are running this random forest classifier and train that. And when we do predictions, one more time, don't forget, on the trained data with the predictions, our model will not have access to their quality estimated, assessed by the experts, but it will be result of our model to work. Good. So we done with training based on the 10 trees in this method. And we can run predictions and show results, show predictions based on the training we did before. And now we can use multi-class classification evaluator to evaluate the accuracy of our prediction. So this evaluator, we need to estimate how it works, if it's good or not. Label column will be label, so the prediction, so the quality for us is. And metric name is accuracy, so we want to measure accuracy. I'm running this one, and we see what accuracy just jumped up from 0.61 to 0.7. So it looks like we are moving in the right direction. I see the question, aren't we overfitting the data? If we would go into the smaller amount of trees, then yes. But you know what? I would ask you, in this case, to try to play with the amount of trees and see if it will work better or not. And then we can talk about that in Discord. So, and we have to say thank you, because it was a great time together, more than 1.5 hour, and we are ready to try to answer some of your questions. In general, live part of the workshop is done, and we will be happy to see you again on all of our upcoming events.
Yes, so we just demo 2 algorithms with our naive Bayes and random forest. If you see on Jupyter, you can also try some FP growth and collaborating filterings, which are more deep dive, but as usual, everything is pretty well designed and written for you. So
yep. So that's an very intro level workshop. It's a big field, and I it's a very big field. So if you want to get a deeper dive into that, now you know at least how it works in general, and it was a very good place to start. But if you want to master that, if you want to become a data scientist, you're definitely going to plan some time accordingly to learn all the required things. Thank you, everyone. I see a question. Can we apply k-means alga to this problem? Good question, simple answer. We could try, but it will not work. So in this case, we work with labels. We understand what quality of this wine is 5 or 6 or 7 or 8 and so on. And we want to see where our new estimation gets. And k-means is a good thing, but doubt if it will work so much for this example, because, well, it's about different thing. It's about grouping things, for example. And yeah, I wouldn't go with k-means for this example, definitely. Last thing I want to say for today, we are preparing something special for you, but before it's ready, we still have announcements of all of our upcoming events on Eventbrite with data stacks. First, we have in action certification exam preparation workshop. Now DataStax has a great special project. So you can become a certified Apache Cassandra expert absolutely for free. Zero expenses. You only need to put your time into efforts into
Efforts, yeah.
Efforts, yeah.
There is no free meal. You still have to practice. But no money at all. Indeed.
Yeah. So that's an associate level exam. And even if you are a beginner developer, if you know how to write code, you can handle these with our video courses. Video courses are available at theacademy.datastacks.com, and how to do and how to prepare for the certification completely explained in this exam. Now, Monday Learning Introduction to Machine Learning just finished. Cloud Native Cassandra Introduction to Cassandra this Wednesday and this Thursday. So hope to see you soon. Next Monday, we have Kubernetes native applications. So it's not easy now. Okay, cloud development and cloud ecosystem and containerization and Kubernetes helps to develop and deliver applications a lot. But that's still making your application efficient is a shared responsibility. It's not only for operations guys to run it into the Kubernetes, but also for developers to understand some requirements. In this workshop, we cover exactly the point: how do you design and write your applications so they will be efficient in the operations time on the production. I strongly recommend this one. And finally, upcoming next week, we will have putting Apache Cassandra on automatic with Kubernetes. And that's how we run Cassandra in Kubernetes. That's for those who are already into Cassandra a little bit. And one more thing I wanted to announce. I hope Cedric will forgive me for announcing a little bit external event, but I speak there. So I hope it's reason good enough to find that. Give me a moment.
Oh, any content we provide, of course, we should promote it more. If you are not subscribed to the channel, you should. I mean, we are live multiple times a week. So twice on Monday. This week is machine learning. Wednesday, Thursday, it will be Intro to Cassandra. And next week, it will be a lot of Kubernetes. Monday, Thursday, and Wednesday will be on Kubernetes. Pretty exciting stuff. With a single Helm recipe, you will get a ton of things running.
Yep. So, and last announcement. So it's going to be Tuesday, November 10th at 6:30 EST. So for European people, it's going to be a deep night. My God.
Yeah, can you copy paste the link?
Yeah.
There's this link on the chat.
Absolutely. You are very right. Good. So that's about designing resilient systems based on Apache Cassandra ideas. I would say it this way. So Apache Cassandra is one of the most powerful distributed systems which is used by nearly all of the companies on top of the world who works with big data spread it over the world. And I'm analyzing the general principles of this system and what makes Apache Cassandra so resilient and so powerful in the question of keeping data and being disaster tolerant and highly available and be able to answer your question within milliseconds in any moment of the time. That's not a particular how-to, that's not a tutorial, but more discussion of the general principles, what makes application more efficient and able to survive any problems and be deployed in every part of the world at the same time.
Yep.
Good. So, that was Cedric Luden, Director of Developer Advocacy at DataStax, and that was...
And Alex.
Yeah. Alex
VOLOCHNEV.
Yeah. And we are very happy what you were here with us, and we can't wait to see you on other events. Now we can meet you only virtually. Hope at some point this pandemic will disappear. And
hopefully
we will meet again on all of the events around the world. So far it's the dream only. And for today, we are done and happy to see you again on the next event. Thank you.
See you soon. Bye.